All right, let's do 6.10 geothermal energy. Sounds good. So geothermal, geo from the earth, thermal is heat, so heat that comes from the earth. It is important to know that the earth makes and generates its own heat. So not just the sun is heating the earth, but the internal heat of the earth is also helping and contributing. And you can see the good old convection arrow down here, so the warm materials rise up, the cooler materials sink down, and this circulation of heat we can use to take the steam that's naturally coming out of the earth. And hey, we all know what we can do with steam. We can spin a turbine and we can make that go to a generator and make electricity. So we don't even have to boil the water because the steam's coming out of the earth already. What? We got to skip a step. Pretty cool. Okay, so geothermal energy works best where there are plate boundaries. So our plate tectonics are coming back into play here. And in case you don't recognize this, this is the Ring of Fire. Ring of Fire! The Pacific Ring of Fire. And it is made mostly from subduction zones. Remember what a subduction zone is? When one plate is diving under the other plate. And this is an ocean plate. And this is usually a continental plate, although sometimes it could be another ocean plate, like Japan. So these subduction zones are very big candidates for using this geothermal energy and harnessing it to make some heat to make some electricity. So here are some geothermal power plants all around the world. And if you notice, they're pretty much where the Ring of Fire was. So this is all the Pacific Ring of Fire area. Hey, there's a lot of geothermal power plants. Hey, there's one in Hawaii. Because you know where else is a good place for that? Volcanoes, wherever there's steam coming out of the earth. So a volcano is a good place too. Remember, Hawaii is not on a subduction zone. It's on a hotspot, which is a plate in the middle, not on a boundary, but it still has this whole volcanic activity. See all these countries here? They are on plate boundaries. That's why we have lots of geothermal areas going on. Iceland has like a bajillion of them because it is separating and it's becoming a crack, and a big geothermal event is there. In fact, Iceland, fun fact, 100% geothermal energy. They use no other kind of energy there. Good job, Iceland. Okay, so the heat from the earth goes up and the hot water gets pumped up. It becomes steam. Again, spins that turbine, makes a generation of electricity with the electrons flowing. Here they are. See those electrons? They're flowing and we get electricity. Same story, just how we make it work. All right, little side note, kind of like solar. So the other thing you just saw was for electricity. This is just for heating your home. This is a little clever thing we've figured out how to do. Same thing I said in the last video. When you compress something and make it smaller, it makes it colder. That's how an air conditioner works, or your mouth. Cold air or hot air. So you can do that with a geothermal stuff in the ground, and you can compress it in the summer to make AC happen, and you can condense it or widen it out in the winter to make heat happen. And it's all just using the heat from the ground that's naturally stored and either compressing it or expanding it to heat or cool your home. And so you don't have, it takes way less energy to do that. So it's kind of a cool little thing you can do. Fun facts of geothermal. Okay, so ups and downsides. So it's a pretty medium energy. It's pretty efficient. It does not have a lot of CO2 emissions, but it does have some. You don't need other fuel to do it, like you don't need something to boil the water because it's already coming out as steam. It does use less energy at the power plant to make this energy occur. It costs a lot to start it, so that's a little upfront thing going on. They're pretty loud. So these are usually out in the deserts and out where the plate boundaries are, but not where a lot of people are because they're kind of annoying. In fact, the loudness actually can scare away wildlife. So it might have a little disturbance on the habitat there. You can only do this where there are plate boundaries, so you can't do it everywhere. There's limited areas where you can have geothermal energy happen. It does release natural carbon dioxide, but it also releases H2S. And in case you don't know what that is, it smells like rotten eggs. If you've ever been to a hot springs or in Yellowstone where Old Faithful is, it's pretty, but it's stinky like rotten eggs. Well, there you go. And since it's from inside the soil, you could have some mercury and you could have some arsenic as well. It uses a lot of water to run the power plant. You are using pretty much the same water over and over, but it uses quite a bit, so some conservationists think that's a downside. And then you can get land subsidence, which is a sinkhole. So the land can start to kind of fall in upon itself. And so that can be a concern as well. Other than that, now you know about the geothermal stuff. Until next time.